Our next lesson is called The Strength of Correlation. So in the last few lessons, you have worked with generating lines of best fit for bivariate data sets. So if I recap, we started the bivariate by doing mostly things by hand, creating a scatter plot, putting in the line of best fit in the middle of the data, and then using that line to talk about if there's positive or negative correlation, and also had a conversation about causation. Does one cause the other? And then after doing that, we got time with the graphing calculator to see that if we enter the data into L1 and L2, we can actually calculate the line of best fit. It gives us an equation. We can have then the slope and the y-intercept. We can interpret what they mean and even use that equation to make predictions about what we will get in this data. So we've already taken a look at that. In every circumstance, the data did not fall on a straight line. We have never answered the question of how well specifically a linear model does in predicting the correlation between the two variables. So that's what we're going to talk about today, how strong the correlation is. So to do that, we have some new calculator strokes that I want to show you. And again, what we're looking at today is how well a linear model is predicting the correlation between these two variables. So in exercise 1, it says be sure to turn your calculator mode set to stat diagnostics on. This setting will turn on the linear correlation coefficient, which is the R value. So let's mark that in some way, highlight, underline. And that's really the only thing you have to do. As long as you make sure that's turned on in your mode, the R value is just automatically going to appear after you run the linear regression that you already learned how to do in the prior lesson. So there's no extra keystrokes. It's not a different calculation. Just make sure that's on and it will show up. So I'm going to demonstrate that for you in exercise 2. It says in the following exercises, 4 data sets with equal X values are given to illustrate different types of positive correlations. So remember, a positive correlation means as X increases, Y also increases. For each, we're going to enter the data. So I'm going to kind of highlight the different things we have to do here. We have to enter the data, so I'll review that with you. After we enter the data, we need to look at the scatter plot, observe the scatter plot. And then we also want to then run the linear regression. So this will be a nice opportunity for us to review. And then what's new to today, I'll use the same color I did up above, is record that R value, known as the correlation coefficient, for a linear fit to the nearest thousandth. So nearest thousandth is 3 decimal places. And then based on the numbers that we're getting, we'll discuss how closely the data lies to the line. So the idea here is if the data lies close to the line, you're going to see a certain type of number than if the data is more spread out and scattered away from the line. And you'll get an opportunity to kind of investigate this as you work through the exercise. So I'll do part A with you. We'll then pause the video and have you try B through E without me. And we'll discuss more further from there. So I'm going to take a look at A, and you're going to want to go to your graphing calculator. And the first thing I want to do is show you how to turn stat diagnostics on. So when you're on the stat diagnostics screen, well, to get to the stat diagnostics screen, you want to just hit the mode key. So the mode key is right next to second. And when you do that, you see all these options. If it's dark, or in other words, highlighted, that means that's what it's set to. So right now it's on normal, float, radian, function, all these things. We need to scroll all the way down. And where it says stat diagnostics, off, if I wanted it off, I would hit enter on off just to show you. So I'm going to arrow over to the right and hit enter. And now I know for sure that stat diagnostics is on. That's the only extra stroke on the calculator that you have to do today. Just make sure that's on your mode screen. And now everything else is going to follow similar to what we did in the prior lesson. So I've got to get that data into the calculator. So I'm going to hit stat, edit, And in L1, I have 2, 5, and 8, and then 11, 15, and 18. Then I'll arrow over to the right. We'll hit enter, then arrow over to the right. And for L2, which will be my Y values, I have 4, 13, 22, and 29, 43, and 52. So now I have my X and my Y values in the table. I am going to make my scatter plot next. That has to be in that order. And again, that's on your notes. So the order that I put it on your notes is the order it always has to be done. Enter the data. Now we're going to look at the scatter plot. So we're going to hit second, Y equals. We're going to turn that plot on. Make sure it's the first option for scatter plot. And then make sure you have markings. Make sure your lists are correct, L1 and L2. And then we should be able to get a picture of the graph. So zoom and pick, remember, option 9. And it should give you the scatter plot. Now, ignore my line. I think that's still there from my other setting. So what we want to move on and do now is we want to take a look at making the line of best fit or the regression line for this data. So we are now going to hit stat, calculate, and we are going to calculate the linear regression with 4. Make sure you have the right list in there, hit enter, and you will get your equation, y equals ax plus b. There's the slope and the y-intercept if I was asking you for the actual line of best fit. And then you also have where you can see underneath finally, because we turn the stat diagnostics on, that you have these R values that are showing up. And that's what we were talking about when we said we want to find the strength of the correlation. So it's the R value we're going to look at, not R squared. That R is 0.998989, etc. Okay, so we enter the data, observe the scatter plot. So make sure you do the scatter plot first. Then you run the linear regression and record that R value. And we're just trying to figure out how closely the data is to the line based on this correlation coefficient. So now that we know our R value, we're going to go to the nearest thousandth. That's 0.999. So let's go back to our notes and record that and talk about what that means. So the value we got for R was 0.999. And that number is extremely close to 1. Let's think about what 1 means. That's a perfect score. 1 is like a perfect score for correlation coefficient. If it was a perfect 1, it would be a perfect line with like an exact slope and y-intercept. And since this is so very close to that, what we would write is that this is very close to the line of best fit, but not perfectly aligned. If it was an exact 1, it would be a perfect line. So knowing that, I want you to practice doing the same thing for B, C, and D. And then in part E, it says, how does the correlation coefficient quantify the fit of a positive correlation? So you don't have to answer part E without me, but I do want you to think about it before you resume the video, and then we'll answer it together. So right now, pause the video and do the same exact thing I just walked you through for B, C, and D. So enter the data into L1 and L2, then make the scatter plot, second y equals, turn the stat plot on and zoom 9 to look at the picture. Then run the linear regression by stat calculate, option 4, record that R value, and tell me what you think that discusses about how closely the data lies in a line. Okay, you had an opportunity to do the rest without me. So remember, you enter the data, make the scatter plot, do the line of regression, record your R value. And what this is going to tell us is how closely the data lies in a line. So when you did that for B, you should have gotten R equals 0.930. That's still pretty high and close to 1. So I said data is still pretty close to lying on the line, but are farther than part A. So it's still really strong and really close to lying on the line, but just not as close as part A because we're at 0.930 and A was at 0.999. When I do the same thing for C, my correlation coefficient R was 0.776. So this shows a distinct positive correlation still, right? We're at about 0.7, but they're much farther from the line of best fit than if we consider what happened in part A. And then in D, I get a correlation coefficient of 0.133. So that's so close to 0, it's very little obvious linear behavior. So doing this exercise has you practice what to do, the steps in order, and it's a nice review of where we've been. And now you see what this R value is going to tell us. It's going to tell us how closely the data lies in a line. So now we can think about this last question together. How does the correlation coefficient quantify, so put a number, to the fit of a positive correlation? And I've kind of discussed that as I've gone over the answers, but what it does is the closer the R value is to 1, the closer the data points are to the line of best fit. So that's why we use the table in A, that one that was 0.999, so close to 1. That's why we said it was pretty much almost a perfect line, but not quite, because 1 is that measurement we're looking for perfect. And the closer you are to 1, the more you're going to be like a line. And that's why part D, so far away, has such little obvious linear behavior. So in exercise 3, the following data is that of two variables that have a negative correlation. So we see the x's are increasing, but the y's are decreasing. So they want us to enter the data, produce the scatter plot, run a linear regression, and record the R value. How is negative correlation reflected in the R value? So let's go to our graphing calculator. We'll do this one together. So I will head to Stat and Edit. I've got to get my data in there. I want to clear out what's in there. So remember, you can go up to the name of the line, hit Clear and Enter, and that'll wipe everything clean. So now we'll move on and enter our new data. We have 2, 5, 8, 11, 15, and 18. Okay, so still the same X values that we had before, so I actually could have left that alone. I'm going to go to L2, though, and enter our Y values of 52, 47, 28, 32, 25, and 10. And we're going to do everything in the proper order. So first, enter all the data in the list. Now we produce the scatter plot. So second Y equals, want to make sure we're on plot 1. I'm going to scroll back up just to make sure we go through the motions here. Make sure it's on. Make sure you have scatter plot chosen, L1 and L2. And then we're going to hit zoom and 9. And again, ignore my line. The line that's on there is from a previous problem. So if you ignore my line and you just look at the dots, you can see as X increases, Y is coming down. So that's definitely showing a negative correlation. So we want to see how this affects the correlation coefficient. So after we enter the data, make the scatter plot, now we can run the linear regression. So we're going to do Stat, go over to Calculate, and we are going to pick option 4, linear regression. Make sure you have L1 and L2 in there. Hit Enter. And we see a correlation coefficient there of R of negative 0.94494, etc. So we'll use that information for our question in exercise 3. So they wanted the R value, and as you saw above, they usually go to the thousandth here. So we'll just stick with that theme as part of exercise 2. And we got R is about negative 0.945 then. So how is the negative correlation reflected in the R value? If the data has a negative correlation, the R value is also negative. So we'll say if the data has a negative correlation, the R value will be negative. So that's nice for us. Okay? So to help you out with this, so you can kind of figure out how strong it is or how distinct it is, we have correlation coefficient here described a little bit better with some examples of correlation coefficient R values, what their scatter plots might look at, and the best words you can use to describe them. So correlation coefficient is a number between -1 and 1, and it indicates the strength and direction of the linear relationship between the two sets of numbers. So we said if it's a positive correlation, the correlation coefficient will be positive, so we know what direction it's going. If it's a negative correlation, the correlation coefficient will be negative, and we know what direction it's going. But it's also going to give us the strength, because the closer you are to 1 or -1, the more perfect or strong the correlation is. So the letter R is used to represent the correlation coefficient. In all cases, that R value is going to be between -1 and 1. So here's going from 1 down to -1, so you can kind of see how it changes. R being exactly 1 is a perfect positive correlation. Almost looks exactly like a straight line. If we go a little bit lower than that, say around 0.8 or anywhere kind of around there, we would consider that a strong positive correlation. Anywhere around 0.2 is a weak positive correlation. And 0 would be the absolute middle, where it's so completely scattered, there's no correlation at all. Then we start working our way down negatives. So -0.2 would be weak negative correlation. Around -0.8 would be strong negative correlation. And then if you're a perfect -1, you're a perfect negative correlation. And you look almost like a completely straight line with a negative slope this time instead of positive. So we're going to take a look at a couple of exercises here, and I actually want you to try these without me. Now that we've talked a little bit more about it and you understand how the negative works, and you now have some pictures of the different options for correlation coefficient and what it means about their descriptions, I'd like you to pause the video and try exercise 4 and exercise 5. So in 4, they give you a scatter plot. You have to draw the line of best fit on the graph and then determine which of the correlation coefficients below would be most likely the representation of the correlation coefficient between your two variables, and explain your choice. So you're going to draw the line of best fit, pick which one you think is the best representation, and then tell me why you picked what you picked. In number 5, which of the scatter plots would have a correlation coefficient closest to -1? So there, again, you're going to pick your choice out of 1, 2, 3, and 4. And then when you're done, you can resume the video to check your answers. So you had a chance to try on your own using the diagram above to help you. Exercise 4, first you had to draw on the line of best fit. If yours is not exactly where mine is, that's okay. But it should be close to mine because we should be laying kind of right in the middle. So the way I placed mine, I'm hitting about 2 of those data points. You can see which ones. As long as you're closest to me, you did fine. And then determine which of the correlation coefficients would best represent that. So when I'm looking at that, it's definitely looking to me like more of a fairly close to the line situation. So when I look at my options, I know it's positive correlation. As X is going up, Y is going up. So I'm going to definitely eliminate number 4. 3, R equals 1 would be a perfect straight line. That's definitely not what we have here. And in choice 2, 0.28 would be very weak positive. So to me, we're more around a strong positive correlation, not a weak one. So option 1 is our best choice here. And my explanation is because there is a positive correlation, first of all, so it's got to be positive. And then the data is fairly close to the line. So that means that's the best correlation coefficient for this situation. In exercise 5, which of the following scatter plots would have a correlation coefficient closest to -1? Well, -1 is a perfect negative correlation. So I'm trying to look for the one that is the closest to perfect out of the 4 options, and that's going to be option 4. 1 is out because it's positive. 3 almost looks like it's so scattered I don't see any linear behavior. 2 is negative correlation, and so is 4. But we want the closest to -1, so the closest to perfect. And 4, those points are going to be closer to the line than they are in 2. So 4 is the best choice. Now moving on to exercise 6, there are 2 primary types of crude oil sold in the world: West Texas Intermediate WTI and Brent crude. Each is priced differently on a daily basis, and each has a correlation with the average price per gallon for gasoline. The 2 linear regression models, along with their R values, are shown below, and they want us to give a prediction for the price per gallon of gasoline Y on a day when Brent price is $103 and the price for WTI is $109. And that variable is our X variable. So in the first one, Brent crude, we're talking about an X value of 103. So we'll take our equation, y equals 0.28, 0.028, and multiply by 103 in for X plus 0.71. When I type that into my calculator and calculate that, I'm going to round to the nearest hundredth, obviously, because we're talking about money. So 2 decimal places. And that means Y is approximately $3.59 per gallon. So we'll write that underneath. $3.59 per gallon. And then for WTI crude, my X value is 109. So that means Y equals 0.031. 109 is going in for X plus 0.67. So again, I'm going to type that in my calculator. I'm going to round to the nearest hundredth because it's money. And Y is approximately 405. So that means here you're paying $4.05 per gallon. So it says, which model would you choose and why? So if I'm looking at this, they both have very high correlation coefficients, 0.973, 0.924. So when I compare them, though, Brent crude's is closer to 1 than WTI crude's, 0.924. So although both strong, when I compare them, Brent crude's is strongest. And if it's closer to being to the line, then my prediction is going to be a better prediction. So Brent crude, because the correlation coefficient for Brent crude, so I'll just write Brent, is closer to 1. Remember, that's our perfect one. This means it is a better prediction. So at this point, we've discussed everything about correlation coefficient. So I would like you to complete this closure question. It says, estimate if the correlation coefficient of the following data sets would be closer to 1, -1, or 0. So those are your only three options. One of these below is a positive one is a negative one, and one is a 0. So you're going to tell me R is most likely closer to, and you're going to give me the number, and then you're going to explain your choice. Why are you choosing what you're choosing? So at this point, I'd like you to pause the video, try the closure, and then resume the video to go over the answers. Here are the answers to your closure questions. So we had to place a 1, a -1, and a 0. So height and shoe size we've talked about before. As X is going up, Y is going up. So I know it has to be positive, which means my correlation coefficient also has to be positive. So I put this with R being most likely closer to 1. My reasoning was because there's a positive correlation. Then weight of a car and fuel efficiency. I know as the weight increases, the fuel efficiency comes down. So that's a negative relationship. So I chose -1 because there's a negative correlation. And then when I was looking at all these, I knew weight in math grades was a 0 because they have no correlation with each other. So there's no correlation between weight and grades. Therefore, that one would have an R value more likely to be closer to 0. And that concludes our lesson on the strength of correlation.